All right, you are welcome again. Today, let's take a look at this question. We are still treating proof of inequalities. We are proving some statements in inequality. And then today, let's take this one. We are asked to prove that GM, that is geometric mean, is less than or equal to arithmetic mean. We are asked to prove that geometric mean, which is GM, is less than or equal to arithmetic mean, which is AM. So in another way round, we can simply say that square root of AB, let's use letters AB, square root of AB is less than or equal to half of A plus B. This square root of AB is the same as saying geometric mean. And then this half of A plus B is the same thing as saying arithmetic mean. Okay? Yes. So we say that we are asked to prove that square root of AB is less than or equal to half of A plus B for all A and B are positive real numbers. For all A and B are positive real numbers. Okay? Yes. Now let's go. Here, what are we going to do? We have square root of AB is less than or equal to 1 all over 2 or half of A plus B. Okay, so this half of A plus B, if you multiply it, is the same thing as saying A plus B all over 2. Hello, it's the same as saying A plus B all over 2. So we have square root of AB is less than or equal to A plus B all over 2. So here we are going to multiply both sides by 2 so that we'll remove these 2 so that it will be linear. Okay, so when we multiply both sides by 2, we are going to have 2 open bracket root AB is less than or equal to A plus B. That is what we are going to obtain. Okay, now this inside this bracket we have 2. In the bracket we have root AB. So this root AB is the same thing as saying root A root B. It's the same thing as saying what? Root A root B. So let's bring it out like this. So we are going to have 2 of root A root B. It's still the same thing. 2 of root A root B is less than or equal to A plus B. Okay? Yes. Now let's take all the terms on the right hand side to the left. So let's go. We're going to take A and B to the other side. So as A is going, it's going to be what? Minus A. And then as B is going to be what? Minus B. But we don't want to have A and B as negative number. So what we are going to have? We are going to divide through. We are going to divide everything by negative 1. We are going to divide through by minus 1. So when we divide everything by minus 1, so the minus A will turn to plus A. And then these are positive 2 of root A root B. It will turn to minus 2 root A root B. Abi? Yes. And then this negative minus, this negative B will turn to positive B. And then this sign of inequality, which is less than or equal to, will turn to greater than or equal to, because when the inequalities are being divided by negative number, the sign of the inequality is altered, is being changed, or will change. All right? Yes. Now that means here we are having A minus 2 root A root B plus B is greater than or equal to 0. Is that true? Yes. Please pay attention to what we are going to do again here. We have A. So when you say root A in bracket raised to power 2, this exponent 2 can actually cancel this root inside. So when it cancels, it's going to give us what? A. That means root A in bracket raised to power 2 is the same thing as saying A. So we said that root A in bracket squared is the same thing as saying A. Is that true? Yes, it's true. So therefore, we have root A all in bracket squared is equal to A. It's true. It's the same thing as saying a. Let's do it here. We're going to have root a, all in bracket, squared, minus 2 root a root b plus. Let's do same to this b. You have root b, all in bracket, squared, is greater than or equal to 0. So here, if we solve this using the method of completing the square, we are going to obtain root a minus root b squared. So we're going to pick this first term, root a, and then minus root b, all in bracket, squared. Both of them are having squared. Is that true? So we're going to simply pick root a minus root b, all in bracket, squared, is greater than 0. Do you know why? Because if you open this bracket into two places now, that is when you say root a minus root b in one bracket times root a minus root b, is going to give you the above expression. So it is in form of a simplified form of this root a, all in bracket, raised to the power 2 minus 2 root a root b plus root b, all in bracket, squared. So when you open this bracket, this root a minus root b, all in bracket, squared, that means we are going to open it into two places. And then when you open it into two places and solve it, we are going to obtain the above term. So therefore, we have solved this and we simplify it. And then we discover that root a minus root b, all in bracket, squared, is greater than 0. You know why we say it's greater than 0? Initially we say that a and b are positive real numbers. Any positive real numbers, the square of it must be greater than or equal to 0. The square of any positive real number must be greater than or equal to 0. So therefore we say that root a minus root b squared is greater than or equal to 0. Hence, we have proven that GM is less than or equal to AM. That is, the geometric mean is less than or equal to arithmetic mean. You see, hence the proof. All right, thank you very much for watching. Please, if you are new to our YouTube channel, please help us subscribe, like, share our videos. All right, yes, thank you very much. Let's take more examples. Thank you. See you next time.